Hello everyone. Today we are going to start with beta functions, and let's start with the definition of beta function. Beta of mn, this is given by 0 to 1 x to the power m minus 1 into 1 minus x to the power n minus 1 dx. So observe two particular things. Limits for this are 0 to 1 and two terms majorly present in the definition. The first term is x power of x and 1 minus x power of n 1 minus x. So when I add 1 to power of x, I am getting this first term, and when I am adding power of 1 minus x 1 to this, I am getting the second term here. So for example, say I have given integral 0 to 1 x to the power 4 and 1 minus x to the power say 5. So if I compare this with the definition of beta function, so in that case the value of m is nothing but I need to just add here so that I'll get the value of 1. Add 1 to power of x, that is value of m, so 5, and then add 1 to power of 1 minus x, so that I'll get value of n, which is 6. This is 5 and 6, right? Similarly, say I have given 0 to 1 x to the power say 5 and 1 minus x to the power 3 by 2. So what is its value? Add 1 to this is 6, and add 1 to this is 5 by 2. So this integral is nothing but beta of 6 comma 5 by 2. So note that m and n both are maybe fractions, maybe only integers, but we are not considering negative numbers here. Okay, so like gamma function, we are not actually using the definition everywhere to calculate this value, but I need to know the format of the definition, because everywhere we are going to compare this format with given required equation, and then we are applying some properties there. Okay, so I need to know the format for the definition. Okay, so let's develop some properties of beta function. So that we can just use that as a tool. Okay, so the first property of beta function is beta of mn, this is equal to beta of n comma m. What is the meaning of this? That the beta function is symmetric. Okay, how to prove this? Let's start with beta of mn. So this is integral 0 to 1 x to the power m minus 1 into 1 minus x to the power n minus 1. Okay, and we have used oftenly the one property for definite integral, that 0 to a f of x, 0 to a, this is same as f of a minus x. Same property we are going to apply on this definition. So this becomes beta of mn equal to integral 0 to 1. Instead of x, I am writing now 1 minus x, m minus 1. Change x with 1 minus x. So this is minus 1, minus minus plus x raised to n minus 1 dx. Let's simplify this little bit. 1 get cancelled, remaining part is x to the power n minus 1 into 1 minus x to the power m minus 1 dx. Now if I compare this with the definition of beta, what it is? This is nothing but beta of the power of x is n minus 1, add 1 to that, so just n, power of 1 minus x is m minus 1. Add 1 to this, so this is m. So what I have proved here, that beta of n comma m, this is nothing but beta of m comma n. That is, beta function is symmetric. Okay. Then the next property we are going to study here is the alternating definition for beta function. So let's see what is alternating definition. Beta of mn, this is also given by 2 times 0 to pi by 2 sine raised to p theta into cos raised to q theta d theta, where p is given by 2m minus 1 and q is given by 2n minus 1. So in case when the given integral is in terms of sine and cos, we are going to use this instead of basic definition. Okay, if the given integral is in terms of x, then you can directly use the basic definition, right? So what we need to prove here, to prove that beta of mn, this is equal to 2 times 0 to pi by 2 sine raised to 2m minus 1 into cos raised to 2n minus 1 theta d theta. Right? Let's start with the basic definition of beta function, that is 0 to 1 x raised to m minus 1 and 1 minus x raised to n minus 1 dx. Correct? Clearly I need to use substitution here. If I substitute x is equal to directly sine theta, then I'll not probably get the power as 2m, because here I am having only m. So just to get this 2, I am substituting x is equal to sine square theta. So what is dx? 2 times sine theta into cos theta d theta. Okay, let's see what are the limits for x and theta when x is 0 and 1. When x is 0, sine theta 0, so clearly theta must be 0. When x is equal to 1, sine theta equal to 1, so in that case I need to have theta is equal to pi by 2. Right? So let's write down the changes in beta function. So now the definition becomes 0 to pi by 2 sine raised to 2m minus 2 into 1 minus sine square theta raised to n minus 1. This is multiplied by 2 times sine theta into cos theta and d theta. Correct? Let's simplify this little bit. So this is 2 times 0 to pi by 2 sine raised to 2m minus 2 multiplied by sine theta is sine raised to 2m minus 1 theta. This is multiplied by 1 minus sine square theta is cos square theta. Cos square theta raised to n minus 1, so that is 2n minus 2, and multiplied by cos theta, so this is cos raised to 2n minus 1 theta d theta. Right? Now let's modify this definition little bit. What we required, yes, we got it, but we will just rewrite the definition. How to rewrite this? What we have, that p is equal to 2m minus 1 and q is equal to 2n minus 1. Right? So using this equation I can conclude that m is p plus 1 by 2 and n is q plus 1 by 2. Right? So just substitute m and n here. So I can rewrite the definition as p plus 1 by 2 comma q plus 1 by 2. This is equal to 2 times 0 to pi by 2 sine raised to p into cos raised to q theta d theta. And that's it. Right? So this is my required definition. So whenever the given equation is in terms of sine theta and cos theta, we are probably going to use the same thing.